Now, suppose any smooth surfaced spherical body is moving in the stationary or steady fluid, or we can say liquid. Then its motion that will be also opposed due to viscosity. How? Say, suppose as shown in this particular figure, we consider large viscous medium. Okay. Now, in this one, suppose a smooth surfaced spherical body is moving like this. Then here the molecules which are in contact with the surface of this particular body will move with body with the same velocity of the velocity of body. But if we think about the molecules of the liquid which are in contact with the wall of this container, then those are steady. It implies that now here, starting from this position of the body, if we move towards the wall of the container, then different layers will move with different velocities. So again, due to this laminar flow produced in this particular liquid, the motion of the body that will be opposed. Scientist Stoke represented the law related to this one. So scientist Stoke experimentally represented this thing. With the help of large number of experimental observations, he suggested this thing: when any smooth surfaced spherical body of radius small r is moving with velocity v in large viscous medium having coefficient of viscosity eta, experiences the viscous force that is 6 pi eta rv. And this force is velocity dependent force, means this is the function of velocity. Means as the velocity is more, this force will be more. If velocity is less, the force will be less. So this one is the Stokes law. Clear? Now, using Stokes law, one can calculate the coefficient of viscosity of the liquid by measuring the terminal velocity of the moving body in the liquid experimentally. Terminal velocity means what? When the body is freely falling in the liquid, then continuously its velocity will be increasing one, but up to certain distance covered in the liquid. After that, its velocity becomes constant. And that constant velocity with which the body continue its motion, that is called its terminal velocity. Now see, suppose as shown in the figure, we consider the large viscous medium. Which one is some liquid having a coefficient of viscosity eta. And suppose as shown in this figure, it is filled in a tube with height more than 100-150 centimeter. Okay. Now the liquid for which we want to measure that coefficient of viscosity. It is filled in this one. And suppose the density of that liquid, that is rho 0. Now, if a smooth surfaced spherical body of radius r is released in this one from the surface of the liquid, so it will move in the liquid. Now, when this particular body is in the liquid, three forces act on the body. One force, that is the weight of the body itself. So weight of the body, that is mg. Suppose here density of the material of this body is rho, then we can say mass of the body, that is volume into density. So we can write mass, that is volume 4 by 3 pi r cube into density rho. So the weight of the body, that is 4 by 3 pi r cube rho g, but weight of the body, that is in downward direction. એટલે મેં અહીંયા એરો કરીને બતાવ્યું છે downward. Another force act on the body when it is in the liquid, that is buoyant force. You already studied about it. Buoyant force, that is equal to the weight of the displaced liquid. Now volume of the displaced liquid, that will be exactly equal to volume of the body. So buoyant force F2, that is m0g, where m0, that is the mass of the displaced liquid, and mass of the displaced liquid, that is volume of the displaced liquid, which is exactly equal to volume of the body into density of the liquid, rho 0, into g, that is the buoyant force, and buoyant force, that is in upward direction. Then after, the third force act on the body, that is the viscous force as per Stoke's law. And viscous force opposes the motion of the body. Body is moving in downward direction, so viscous force, that will be in the opposite direction of motion, so in upward direction. And that is given by Fv equal to 6 pi eta Rv. Now total three forces are acting on the body, so we can write the net force acting on the body, or net force acting on the sphere. F, that is equal to F1 minus F2 minus Fv. Resultantly body is moving in downward direction, so that direction is considered positive, so opposite to it are negative. Okay, now net force F, that is equal to F1, the weight of the body, 4 by 3 pi r cube rho g. F2, the buoyant force, that is 4 by 3 pi r cube rho 0 g. Fv, that is 6 pi eta r v. So this one is the net force acting on the body. Clear to all of you? Now see this equation of the net force. Weight of the body, 4 by 3 pi r cube rho g, constant 1. Buoyant force, 4 by 3 pi r cube rho 0 g, constant 1. In this particular viscous force, 6 pi eta r, all are constants, but velocity is not constant. Net force, that is mass into acceleration, it implies that at present the body is executing accelerated motion, and accelerated motion means this velocity is continuously increasing one. એટલે હવે શું થશે, જો F1 constant છે, F2 constant છે, and due to increasing velocity this force Fv is continuously increasing one. So definitely after some time the situation will be like this. The summation of F2 and Fv, that will be exactly equal to F1. So suppose after time t, for a velocity, say it is v equal to vt, F2 plus Fv becomes exactly equal to F1. હવે જો F2 અને Fv નો સમેશન F1 જેટલો થઈ જાય, then the net force will be 0. And during the motion, if net force acting on the body that is 0, then as per Newton's laws of motion, we can say body will move with constant velocity. It implies that this particular velocity vt, for which the net force becomes 0, that velocity now is constant. So we can say body will now move with this constant velocity, and that is known as terminal velocity. So now at time t equal to t, for velocity equal to vt, we can write f equal to 0. So 0 equal to 4 by 3 pi r cube rho g minus 4 by 3 pi r cube rho 0 g minus 6 pi eta r vt. V is replaced by vt. Now take this term of viscous force on left hand side. So 6 pi eta r vt, that is equal to. Now on right hand side, from these two terms you can take 4 by 3 pi r cube g common. So into bracket rho minus rho 0. So now here you can write two equations. Vt equal to 2 by 9 r square g upon eta rho minus rho 0, or eta equal to 2 by 9 r square g upon vt rho minus rho 0. So experimentally, if you measure the terminal velocity, then you can calculate the coefficient of viscosity. And if the coefficient of viscosity is known one, then you can calculate the terminal velocity of the body in that particular liquid. Clear? Now see here, rho is greater than rho 0, and body is moving in this direction, which is considered as positive direction. So your velocity, that is positive. Suppose we consider the spherical body, which one is in the liquid, having density is less than the density of liquid, rho is less than rho 0. तो આ ટર્મ નેગેટિવ થાય, તો વેલોસિટી નેગેટિવ આવે. મતલબ કે અત્યારે આ ડાઉનવર્ડ વેલોસિટીને આપણે પોઝિટિવ કહીએ, તો નેગેટિવ વેલોસિટીનો મીનિંગ એ થાય કે બોડી મૂવિંગ અપવર્ડ. અને નેચરલી જુઓ એવું થાય છે કે આ લિક્વિડની અંદર જો તમે એર બબલ ઇન્સર્ટ કરી દો, તો for air the density is less than density of the liquid, તો air bubble ઉપર મૂવ થાય છે. Clear to all of you?